Hi guys, today we're going to be looking at what makes up matter. So when we're looking at matter, matter is anything that has a mass and that takes up space. And an object's mass is the amount of matter that it contains. It's different than what something weighs. When we look at what something weighs, we're taking into account gravity. And gravity is unique depending on where you're at. Everywhere on Earth it's the same, but if we were to go to the Moon, Mars, or Jupiter, gravity would be different. So you would weigh different in those locations. However, your mass will always stay the same no matter what. So, for example, at the bottom of the page here, if on Earth a person weighs 80 pounds and then decided to travel to Mars, that person would then weigh about 30 pounds. And then if they went to Jupiter, they would weigh about 187 pounds. But no matter where they were at, their mass would always stay the same, and it'd be about 36 kilograms. So mass is universal. It would always stay the same. Now, a particle is matter, and they're very, very tiny units of matter. They have small masses, and they take up very little space, but together particles help form larger units of matter. Now, the smallest unit of matter and basic unit of a chemical element that we're looking at is an atom. And an atom, here in the corner we have a model, is made up of 3 different types of particles. So in the very center of an atom, we have something called the nucleus. The nucleus is made up of protons and neutrons. A proton has a positive charge, where neutrons have no charge. And you can help remember that by what they start with. Protons, positive, P, neutrons, no charge, N. Outside of the nucleus, we have our third particle, an electron. And an electron has a negative charge. So together these make up an atom. Now there's many different types of atoms, depending on the number of protons that are found in there. Some atoms have 1, some have 5, some have 6. And when a bunch of the same type of atom get together, we end up with something called an element. And elements are arranged on the periodic table, and you guys have probably seen these posters up around the room. And an element is very unique. So, for example, if we take a look at oxygen, oxygen is an element made up of oxygen atoms. And each oxygen atom has 8 protons, and we know that because of the atomic number. Every element on the periodic table has an atomic number, an element symbol, and an atomic mass. The atomic number tells us how many protons are found in the atom. The symbol is just a way to abbreviate and let us know what element we're looking at, and then there's also the atomic mass listed. If we were to look at a different example, say hydrogen up here in the corner, hydrogen then would have 1 proton in its atoms, and its element symbol is an H. Now when we get a bunch of elements bonded together, we end up with something called a molecule. And a molecule is just when 2 or more elements are held together by chemical bonds. Those atoms could be the same, so we could have 2 oxygen atoms come together and we have O2, or we could have 2 hydrogen atoms come together, 2 nitrogen atoms come together. They could also be different. Here we have Na, which is sodium, and Cl, chlorine, that are bonded together and they make up table salt. Or we have 2 hydrogens here with an oxygen, and that makes up a water molecule. Now, a compound is also when 2 or more elements are bonded together, but in a compound, they have to be different. Remember when we were looking at molecules, you could have 2 of the same. A compound, it has to be 2 or more different elements bonded together. So our example of water, water still counts as a compound because we have 2 different, we have hydrogen and oxygen. Down here, this weird chain-looking thing is C6H12O6, and this is in your foldable. This is glucose. So we have 6 carbons, 12 hydrogens, and 6 oxygens, all bonded together to form glucose, or sugar. So all compounds are molecules, but not all molecules are compounds. Remember, molecules are anytime they're bonded together, but a compound you have to have 2 different elements. And lastly, we have something called a mixture. And a mixture is a system made up of 2 or more different substances that are mixed but they're not bonded together. So if we think of Raisin Bran cereal, you have the raisins and you have the cereal flakes. Or if we take a look at this chicken noodle soup here, we would have the noodles, the chicken, the carrots, and the broth. They're all mixed together, but they're not bonded together. Now there's two specific types of mixtures. A heterogeneous mixture is a mixture made up of different substances that remain separate. So if we took a bag of M&Ms, you could separate out the colors. Or if you have trail mix, you could separate out physically the different pieces of the trail mix. Now the other type of mixture is a homogeneous mixture. And a homogeneous mixture, the components that make it up are all evenly distributed, and they're also the same phase. So if we look at one example, they would be all gases, like in air. There's many different types of gases that make up the air that we breathe. Or you could have all liquids or all solids. So homogeneous, they're the same. That's our root word here. Same, and they're evenly distributed throughout. So remember, what makes up matter? Well, it's anything that has mass and takes up space. And we have atoms, elements, molecules, compounds, and mixtures. So remember, you're living, you occupy space, and you have a mass, so you matter.